The notes for section 9.2. Okay, section 9.2, page 515, 1 to 69 odd. Some problems there. Some more there. Some more. Turn the page for a few more. Okay, so up to 69. So that's that. Okay, then the answers in the back of the book. 9.2. Up to 69, you should be able to see there. And let me move over to the right for the ones that got cut off on the far right there. And there we go. Okay. All right, so we're simplifying radicals. We've actually done some of this before. Okay, so let's see what's happened here. So square root of 8, what you want to do is write it as a perfect square times something else. So 8 is 4 times 2. And then the square root of 4 comes outside as a regular 2. So 2 radical 2. Okay. Number 3, square root of 98. 98 is 49 times 2. So how do you know that? You don't. Just try stuff. Try taking out a perfect square, or you know this is even, so if you take out the 2, you would notice this is 2 times 49, then hopefully you say, oh yeah, 49, square root of 49 is 7, so 7 radical 2. So you want to take perfect squares out. 80, perfect square is 16, 16 times 5, 16 comes outside, changes to 4, so 4 radical 5. Okay, 11, 675. Okay, well, that's divisible by 25. Happens to be 25 times 27. So 25 comes outside, changes to a 5, radical 27. But in this case, you're actually not done. 27 is 9 times 3. So take out the 9, 5 times 3, radical 3, 15 radical 3. Okay, 13 cube root of 54. So I have to think of perfect cubes, like 27. 27 times 2. The cube root of 27 comes outside and changes to 3, and stuck inside is a cube root of 2. The cube root of 128. So on my perfect cubes list is 64. Okay, 128 is 64 times 2. And then the cube root of 64 is 4, so 4 times the cube root of 2. 21, square root of 18x cubed. So 18 I'm going to write as 9 times 2. I don't want 6 times 3 because neither 6 nor 3 is a perfect square. I want to take out perfect squares. So 9 times 2. X cubed treated as x squared times x. Okay, we're assuming x is a positive quantity or non-negative, strictly speaking. Okay, square root of 9 comes outside as a 3. Square root of x squared comes outside as an x. So 3x radical 2x is still inside. 25, cube root of 40, x to the 4th, y to the 7th. So I'm going to write this as a perfect cube. I want to write that as a perfect cube, namely x cubed. I want to write that as a perfect cube, namely y to the 6th power. Okay, 40 is 8 times 5, because this is going to come outside and become a 2. X to the 4th, write as x cubed times x. Y to the 6th, write as y squared times y. So in red are all the perfect cubes. Okay, the cube root of 8 will come outside and become a 2. Cube root of x cubed will become an x. Cube root of y to the 6th is y squared. So outside 2xy squared, and left inside are the cube root of 5x and y. Okay, 33, we want perfect fifth powers. Okay, basically, you want all of these to be multiples of 5. This is already good. That's a multiple of 5. This is a multiple of 5. This is x to the 7th. So I'm going to write that as x to the 5 times an extra x squared. Now, believe it or not, the fifth root of 243 is a nice number. That's 3. Okay. So how do you know that? Just try 3. 3 times 3 times 3 times 3 times 3 is 243. Okay, so that'll come outside. And we said change this to x to the 5th, x squared, and these are already good. Okay, so this will come inside as a 3. The fifth root of x to the 5th is x. The fifth root of y to the 10th is y squared. It's essentially 10 divided by 5 is 2. And the fifth root of z to the 5th is z. So outside is 3xy squared z, and left-hand side is the fifth root of x squared. Okay, 35, it says find b squared minus 4ac. So b squared minus 4ac, part of the quadratic formula. So square root of b squared minus 4ac, b squared is a positive 36, minus 4 times a, which is 2, times c, which is 3. This here comes out to be 24. 36 minus 24 is 12, and 12 is 4 times 3. Take outside the 4, 2 radical 3. Okay, 39 is a little bit harder because of the fractions. This is my a, b, and c. I'll leave that as a may. So b squared, negative 1/2 squared is positive 1/4, minus 4 times a, which is a half, times c, which is negative 5/4. Okay, so that's going to give me a double negative right here and right here, so I'll make it a positive. I'm going to cancel that 4 with that 4 very conveniently. So I have 1 times 5 divided by 2. So 1/4 plus 5 halves. Common denominator is 4. Multiply this by 2 over 2. So I have a denominator 4. 1 plus 10 is 11. Square root of 11 over 4. Square root of 4 comes outside as a 2. Can't do anything with that, so leave it radical 11 over 2. Okay, then 41, which actually has 4 parts, A, B, C, and D. Okay, square root of 20 over 4. Right, 20 is 4 times 5. Okay, not 2 times 10, because neither 2 nor 10 are perfect squares. Square root of 4 is good, because that's going to come outside and change to a 2. So 2 radical 5 over 4. 2 and 4 cancels, leaving me with a 2 in the bottom. Radical 5 over 2. Okay, B, 3 radical 20 over 15. The 3 and the 15 cancel out, leaving me with a 5 in the bottom. So I have the square root of 20 over 5. Well, square root of 20, we just did that over here. 4 times 5. 4 comes outside and changes to a 2. 2 radical 5 over 5. And leave it. In case you're wondering, no, you cannot cancel these out. You don't cancel something inside a radical with outside the radical. Now, if they're both outside, yes, you can cancel. If they're both inside, yes, you can cancel. But one inside and one outside can't cancel. Okay, C, 4 plus radical 12 over 2. So I work on the square root of 12. That's 4 times 3. Okay, I made a mistake. There's no plus or minus, just plus. 4 times 3. 4 comes outside and changes to a 2. And now since this, and this are all even, I can divide. So I'll divide 4 divided by 2 is 2. 2 radical 3 divided by 2 is just radical 3. And finally, D, 2 plus radical 9 over 5. Well, radical 9 is 3. 2 plus 3 over 5. 5 over 5, so 1. Okay, so that's that. Now for problems from 45 on, we want to do something called rationalize the denominator. Make the denominator nice. Okay, why we want to do it? Well, you might sometimes have to get a common denominator. So if you want a common denominator, you don't want a square root there. You'd rather have a nice denominator. Now, in the process of doing that, the square root might migrate to the numerator, but that's okay. I don't mind having a square root in a numerator. I just don't want it in a denominator when I have to fool around with common denominators. So here's what you do. 2 over radical 3. Just multiply top and bottom by radical 3, whatever you see in the denominator in this case. Because radical 3 times radical 3 is just 3. So 2 radical 3 over 3. Same thing here. 5 over radical 6. Just multiply by radical 6 over radical 6. And these two will combine to just give me 6. So 5 radical 6 over 6. Square root of half. Split it into 2. You're allowed to break it into square root of 1 over the square root of 2. And just multiply top and bottom by square root of 2. So that gives me square root of 2 over 2. Radical 2 times radical 2 is 2. Yes, you could say radical 2 times radical 2 is radical 4, but the square root of 4 is just 2. Okay, now if you have a cube root, it's a little bit different. Okay, you can't multiply by the same thing like over here. If you multiply by another cube root of 2, you'd have the cube root of 4, which is still not nice. So what you want to do instead is you want to bump this up to be an 8, because I know the cube root of 8. So I have to ask myself, how do I force this to be an 8? I multiply by the cube root of 4 in this case. So on top I have 4 times the cube root of 4. The bottom becomes the cube root of 8, and the cube root of 8 is now 2. Okay, and 4 divided by 2 is 2. So final answer, 2 times the cube root of 4. Okay. Same kind of game here. 2 over cube root of 9. That's 9. So what number do I want to bump it up to get a nice perfect cube? I want this to be a 27 because I know the cube root of 27 is 3. So that tells me I'm going to multiply by cube root of 3, top and bottom. So on top I have 2 cube root of 3 over cube root of 27, and the cube root of 27 is 3. Okay? And in case you're wondering, no, don't cancel. Remember, don't cancel inside and outside a radical. Okay, here's 57. Fourth root now of this thing. So break it into 2 first. Fourth root of 3 over fourth root of 2x squared. So how do I want to bump this up? So what number has a nice fourth root? 16, which tells me to multiply by 8. And I know the fourth root of x to the fourth. So how do I bump this up to x to the fourth? X squared. So there we go. Fourth root of 8x squared, fourth root of 8x squared. Okay, now both of these are fourth roots, so I can combine them. That'll be what? 24x squared, fourth root. Okay, the bottom becomes the fourth root of 2 times 8, which is 16. X squared times x squared is x to the fourth. And now this is nice. I mean, that's not really any surprise. I forced it to be nice. The fourth root of 16 is 2, and the fourth root of x to the fourth is x for positive values of x. We're only considering positive values of x. And that's about it. Don't try to cancel anything. Again, you can't cancel inside with outside. Okay, cube root of 4x over 3y. So again, first split it into 2. Cube root of 4x, cube root of 3y. So how do I want to bump it up? I know the cube root of 27. And I want to force this to be y cubed. So what do I multiply if I want to get 27? 9. How do I bump this up to y cubed? Y squared. So cube root of 9y squared, top and bottom. And these are both cube roots, so you can combine them. 4 times 9 is 36, xy squared. The bottom is 3 times 9 is 27, y times y squared, y cubed. This is a perfect cube because I made it that way. I forced it to be a perfect cube. So the cube root of 27y cubed is just 3y. So here's my final answer. And finally, 67, last one we'll do. Square root of this, split it into 2, like this. So there's 2 things going on. Fortunately, it's a square root. So how do I clean up the square root? Just like these over here, just multiply top and bottom by radical 2z. Okay, but while I'm at it, let me try to clean this up. Let's see, 75 is 25 times 3. X cubed treated as x squared times x. And y squared is perfect. Okay, so this will come outside and change to 5. That's x, that's y. So leave the bottom alone. 5xy. Stuck inside is the square root of a 3 and an x. Radical 2z. Okay, now multiply top and bottom by radical 2z, because the bottom, radical 2z times radical 2z is just 2z. I'm allowed to combine these. So 5xy square root of 6xz all over 2z, and that's about it. Just leave your answer like that. Okay. All right, so this was section 9.2.